today this is the calculation analysis for RK4. Before starting our calculation analysis, we have three files that should be in front of us: RK4 data, RK4 derivation, and RK4. In the manual, the first report requirement is derive the equation for outlet concentration of caustic soda from the back titration. Also calculate the tau for each run. So when we open the data here, we have here the volume for the volume of back titration that was performed in the experiment for each time, and we have run 1, run 2, run 3, and we have the flow rates. To calculate tau, which is easy, you divide, which is the space-time and easy, you divide the volume, you take the volume divided by 101, which is the volume of the reactor, divided by the flow rate, and so on. You do the same thing for the second run, will be 400 divided by 200, and the third run 400 divided by 300. After that, you open RK4 derivation. In the derivation, we want to drive the equation that converts volume titrated to concentration of caustic soda. So to drive the outlet concentration, you have 25 milliliter sample of unknown NaOH concentration is taken from the reactor and quenched with 25 milliliter of 0.05 molar HCl. This means all of the NaOH in the sample will react with the excess HCl. To get after this back titration occurs, and to get the concentration of the unreacted HCl, you perform titration to get the volume of 0.05 molar NaOH required to neutralize the unreacted HCl to calculate volume titrate. And this is what has been done in the experiment, and this is the numbers here which are in the data: volume titrated here, here, here for each one. And this is the equation that governs the reaction. 1 mole of HCl reacts with 1 mole of NaOH to give NaCl plus H2O. Therefore, the total number of moles of HCl will be 25 multiplied by 10 to the power minus 3 liter multiplied by 0.05. 10 to the power minus 3 liter is to convert from milliliter to liter. And the number of unreacted HCl, number of moles of unreacted HCl will be volume titrated multiplied by 10 to the power minus 3, again to convert from milliliter to liter, multiplied by 0.05 mole over liter NaOH. Because 1 mole of NaOH reacts with 1 mole of HCl, therefore the number of number of moles of unreacted HCl will equal to the number of moles of NaOH used in titration. Therefore, the number of moles that reacted with NaOH sample during the quenching process will be 25 multiplied by 10 to the power minus 3 multiplied by 0.05 minus volume titrated multiplied by 10 to the power minus 3 multiplied by 0.05. Therefore, the concentration of NaOH in the sample will be the number of moles that was calculated divided by the volume of the sample, which is 25 multiplied by 10 to the power minus 3. 10 to the power minus 3 will cancel out with 10 to the power minus 3, and we will have 25 minus volume titrated multiplied by 0.05 divided by 25. This 0.05 is the initial concentration of caustic soda. Therefore, the equation used will be 25 minus volume titrated multiplied by CaO, which is the initial concentration of caustic soda, which is 0.05, divided by 25, which is the volume of the sample that was taken from the reactor. Therefore, for each time, you will take this volume titrated, substitute it into this equation to convert it to concentration for all times and for all runs. You will do this for all times and for all runs. In the previous video, we performed the first report requirement. In this video, we'll be talking about the second report requirement in the experiment RK4 and the third report requirement. So the second report requirement is you have to find the order of the reaction and the rate constant of the reaction from the literature. So when doing so, when serving the net and trying to find the order of the action and the rate constant, you may find the order of the action and the rate constant at different temperature than the temperature of this reaction. So we are going to be using Arrhenius equation to convert from that temperature to our temperature, which is 20 degrees. Therefore, let's go to report requirement number 3. Report requirement number 3 is substitute the rate expression into equation 8 and integrate to find the performance equation of the reactor. So we'll go to the file RK4 open it. So it states, the report requirement states that you have to substitute the rate expression into equation 8. Equation 8 in your manual will be tau is equal to volume divided by the volumetric flow rate is equal to minus integration initial concentration to the final concentration, or the required concentration to calculate the tau, dCA divided by the rate expression. We have our rate expression here is K multiplied by Ca to the power of n. Ca is the limited reactor here, and the limited reactor in this equation, in this reaction, is NaOH. K is the rate constant and n is the order of the reaction. As after finding the rate constant and the order of the reaction, usually you will find that the order of action is 2, and the rate constant you will find it from the literature. Substitute this equation, this rate expression, into this equation, and then perform the integration from Ca naught to Ca. Don't plug in the values, just perform the equation, and then present the final form of this equation. Report requirement number 4 is evaluate both theoretical and experimental values of conversion for each run. Okay, so let's go back to RK4, file RK4. So we did the third requirement and we did the integration. So to calculate the theoretical conversion, you're going to calculate tau as done in step 1. You have tau is equal to the volume of the reactor divided by the flow rate for each run. Use the expression that you find from the report requirement number 3 and calculate Ca for each run. So in this equation, after finding the final form, you have tau, which is a number, and it's easily calculated. You have Ca node, which is also 0.05. The only requirement will be Ca, and you know K and you know N. The only unknown is Ca. You find Ca for each run, and then you calculate conversion, which is Ca node minus Ca divided by Ca node. After that, to calculate the experimental conversion for each run, you will use the same equation. X is equal to Ca node minus Ca divided by Ca node. Ca node is 0.05, but in this case Ca will be you will get it from your data. So the last volume titrated is converted to Ca. Use this in this equation, and this will be experimental conversion. This will be the experimental for RK4 will be plot the experimental conversion versus space-time and compare with the theoretical prediction. Explain your deviation. So in the last requirement, we'll go back to RK4. You'll plot the theoretical conversion versus tau space-time for each run, and then plot the experimental conversion versus tau space-time for each run on the same plot. You will have a straight line, and if the data is correct and all the calculations are correct, the two lines should be very close to each other. If there is deviation, you have to explain this deviation. Thank you for listening.